Hey there, it's time to practice factoring some quadratic expressions using the techniques that we've learned. On the left, we've got 4 problems, and on the right, we've got 4 slightly more difficult problems. So why don't you pause the video here, try them out yourself, then come back and we'll do them together. All right, let's try them out. So this first one here, well, we can think about using what we call the AC method, right? So the AC method requires us to multiply the numbers here that we have for, here is C, and A is going to be 1, right? And so in this case, it's just going to be equal to 1 times 12, which is just 12, okay? And so when our sort of coefficient here is just the number 1, it's pretty easy. We just get this number 12, and the idea is what we're looking for is we're looking for 2 numbers that multiply together to give us the number 12, right? So we're looking essentially for the factors of 12, and then they want to add together to give us the value of 7, right? Whatever is our number for B in our expression here, right? And so that's essentially what we're looking for, okay? So we're looking for essentially, we think of this as some ax squared plus bx plus c, and so we multiply a and c together, but a is 1, so it's really just c, and the factors of c will add together to give us b. Okay, so let's do this. Let's try and find the factors of 12. Well, we're going to have, we have 1 times 12, 2 times 6, 3 times 4. We could do 4 times 3, but that's just repeating, right? So now which pair of factors is going to add up to give us 7? Well, 1 plus 12, well, that's going to be, it's going to be 13, so not that one. 2 plus 6 is going to give us 8, so not that. 3 plus 4 is going to give us 7. Yeah, that's what we're looking for. Okay, so we're looking for these 2 numbers here. Okay, and so what do we do with these 2 numbers? Well, we're going to say then the factored form of this original expression is going to be actually x plus 3 times x plus 4. Okay, that's the idea here. And if you wanted to test this and FOIL it out, we could do that, right? So we could FOIL these 2 factors together, these 2 binomials. We'll get an x times an x, that's an x squared. Outer times outer, that'll give us a 4x. Then inner times inner, that's going to give us a 3x. And finally, last times last, that's going to give us a 12. And we simplify this, we're going to get x squared plus 7x plus 12. And yeah, that's what we're looking for, right? That's exactly what we have here. And so, this is going to be the correct factored form of our original expression right over there. Okay, so let's try the next problem. We're going to use the same method here, okay? So let's just go through it a little bit faster. Essentially, we're looking for the 2 numbers that add up to 6, multiply to give us 6, and add up to give us a negative 5. Okay, now this is a negative number here. So let's think about how we can get a negative 5 here. So our factors would be, 1 times 6 and 2 times 3, and then, 3 times 2, that's the same thing. But none of these factors, when you add them together, will give us a negative 5, right? This would give us a 7, and this would give us a positive 5. How can we possibly get a negative 5? Well, it turns out we can also multiply 2 negative numbers together to get a positive value here. So what we're saying is we could actually multiply negative 1 times negative 6, and that would give us positive 6. Likewise, negative 2 and negative 3 multiplied together give us negative 6. And so now we can see that this combination here is actually the one that we're looking for, right? Because negative 2 plus negative 3 will give us negative 5. Okay, so when you have a positive value here for C, you know that the factors over here are both going to have the same sign. They could both be negative like they are here, or they could both be positive like they are here. And you just have to look at the value of B. If B is positive, the factors must be positive because they're going to add to give you a positive number. And if B is negative, then the 2 factors must both be negative because they add together to give you this negative number. All right, so that's sort of the logic behind that. But we can just write down our answer here. Now it should just be x minus 2 times x minus 3. Okay, that should be it. We can check, right? First times first, x squared, that's always good. Last times last will give us that positive 6, okay? That's guaranteed because that's how we found those numbers. Really, it's the middle term that we have to be concerned about. And so if we do outer times outer, we'll get a negative 3x. Inner times inner is a negative 2x. That does, in fact, equal negative 5x. So yes, this is what we're looking for. This is going to be the factored form of our original expression. All right, let's take a look at this one now. Okay, so what we're doing here is a little bit different. Our value for a is no longer 1. We need to work with sort of the general form here where the value of a could be something else. How do we do this? Well, the whole point is that we want to factor this into a product of two binomials, some kind of x plus something times an x plus something else. And if you remember in the past, we wrote down sort of symbols here that we could use. We could say this was a px, this was a qx, this was going to be an r, and this would be an s, right? And the idea is that when you multiply these together and you FOIL them through, we see that, well, let's see. So if we try to FOIL this, the first times first term here, this would give us some kind of pq x squared, right? And the last times last, well, this would just give us some kind of r times s, okay? And now inside here, we're going to get some other terms, right? We're going to get an outer times outer plus inner times inner times inner. Let's not worry about that right now, because what this is showing us is that the value for a must be this PQ, and the value for C must be this RS. And so we practice sort of this trial and error method, where essentially what we did is we took this 2 and we took this 3 and we tried to find the factors of each of them. Okay, so basically the factors of 2 are going to be 1 and 2. The factors of 3 are 1 and 3, right? These are both prime numbers. 2 and 3 are both prime numbers, so the factors are very, very simple. And so the whole point is that there must be some product here where you have, for example, these are represent the P and the Q. These are the first terms, right? So this must be some kind of 1x. Here we'll have a 2x. And then these must be the last terms. So this must be a plus 1, and this could be a plus 3, right? So what I'm saying is we can look at sort of the first and the last of these terms here. And we want to multiply these together such that we reproduce this same original expression. Okay, so let's try this. Let's try foiling this out. Okay, what we're going to get is this kind of 2x squared, outer times outer. This will give us a 3x. Inner times inner will give us a 2x. And then last times last will give us a 3. Okay, and if we simplify this, we get 2x squared plus 5x plus 3, and this is wrong, okay? We wanted a 7x, not a 5x. What happened? Well, what happened is that there's another combination we have to unlock to try out. Okay, so this trial and error method involves getting the combinations of factors for A and for C, and then figuring out what order they actually have to be in to get the right answer. There is another combination we have here if we flip the 1 and the 3, right? The factors here on the last term, if we flip them, then we have another combination we can try. So that would actually now be, so first and first, that's going to be x here and a 2x here. And then these are the two last terms now, so we can try plus 3 and plus 1. Now, if we FOIL this, look at what we get. We're going to get our x squared plus outer times outer. It's going to be x plus inner times inner is going to be 6x and then plus 3. We simplify to x squared plus 7x plus 3. This is what we want. These are going to be our true factors of the original expression. Okay, so the trial and error method works by finding all of the combinations. Now, in this case, for prime numbers, when you have prime numbers for A and C, it's not too bad. It's pretty simple because there's only going to be one pair of factors for each. And then you can just sort of flip the last one to try to unlock that extra combination. So we're really only trying two possible combinations of factors. But If these were in fact not prime numbers, but sort of compound numbers with many different types of factorizations that you can find, things get a little more tricky. You're going to have a lot more combinations, especially if one of them is negative. Let's take a look at this next one here. Maybe you'll see what I'm talking about. Okay, so once again, we want to find the factors here of this A and the factors of this C. Okay, and so if we do that, basically sort of the first times the first terms in our factors and the last times the last terms here, right? What are they going to be? Well, for 4, the factorizations are 1 times 4 as well as 2 times 2. Okay, so those are the possible options. For 6, we can have 1 times 6 or 2 times 3, but now we have to also remember we can flip these to unlock extra combinations. So that could be 6 times 1 and 3 times 2. Okay, so there's 4 different options here, but it's going to actually be more than that because it's going to be possibly 1 and 4 as the first terms, and then 1 and 4 paired up with 1 and 6 as the last terms, or paired up with 2 and 3, or 6 and 1, or 2 and 3, or 3 and 2 as the last terms. But then we also have the ability to check, it might actually be 2 and 2 for the first terms with each of these. Okay, so we actually have to sort of double all of these combinations here. It's going to be a 1 and 4 for each of these possible pairs of factors there, and then 2 and 2 is also going to be the same, so we have to duplicate these, and now we can try pairing them up with the 2 and 2 as the first terms. Okay, so look at this now. We're actually going to have 8 combinations total, which is a lot of combinations, and the more different factorizations you get for these different numbers, you can see this is going to, number of combinations is going to grow very quickly. Okay, so very quickly this becomes impractical. Now with this, there is a technique that we can use to try and do these, run through these combinations faster, right? So what I like to do is, essentially think about the outer times the outer and the inner times the inner. We're reverse foiling, right? We're taking these combinations, we're going to try and reverse foil them into seeing, or foil them together and see if we can get the original expression, right? So the idea is that if we take this original one here, this is telling us to try a combination of 1x and 4x as the first terms, plus 1 and plus 6 as the last terms. Okay, so that's the idea here. Now, what do we get? So let me color code this. Okay, so let's color code this blue, and this is our outer term blue, green, and green like that. Okay, so what we have here is this is our outer term, this is our outer term, this is our inner term, and our inner term. When we foil this, we're going to get, first times first is going to be 4x squared. Last times last is going to give us a 6. We're guaranteed to always get that because that's how we got these numbers to begin with, right? These are going to be the factors of 6 and these are going to be the factors of 4. So we're always going to get those. But it's the middle term that's important. Okay, so here we do outer times outer. Okay, so outer times outer, this is going to give us then 1 times 6x, right? And then over here, we're going to get inner times inner. That's 1 times 4x, okay? And we want to then add these together. So this is going to be 6x plus 4x. This is going to be a 10x. And that's what we want to compare. Does 10x equal 11x? No, it does not, okay? And so this combination doesn't work. I can do this for every single combination of factors, but look how tedious that is, right? So we're not going to do that. Instead, what we're going to do is we can sort of compress the math, right? We can compress the math here by just thinking about the outer times the outer and writing down that number right here. That's going to just be 6, right? And then we're going to add this to the inner times the inner. That's going to be 4. And what's that going to be? That's going to be 10. And so I can see here clearly that doesn't work. Okay, so I'm not going to write it all of the stuff down here. I'm just going to do it in my table, right? So here, what is outer times outer? Well, that's going to be a 3. Let me 3. What's inner times inner? Well, that's going to be an 8. What is 3 plus 8? That is 11. Is that what we're looking for? Yes, it is. Okay, so we've actually found the correct combination on the second try. But you're not guaranteed to always get it so early. You might actually have to keep going down to get more. Okay, but what that's telling us is that I'm actually going to erase this because that was just to illustrate a point. What we have here as the correct combination should then be, so these are the first terms. That's going to be x and 4x. And then the last term should be a 2 and a 3, right? And so if we do the outer times the outer, we're going to get here a 3x plus, here we can see inner times inner is an 8x. That is 11x. That is good. This is going to be then the correct factorization. Now, this method is annoying because you get so many combinations. And so instead, what we would prefer to do is use what we call the AC method, okay? And what is the AC method? The AC method is where you're going to take the values for A and multiply it by the value for C. In this case, it's 4 times 6. And that gives us 24. And then what we're going to do is we're going to do a smaller table here. We're just going to look for the factors of 24 that add up to give us B, that add up to give us 11. Okay, so let's write down here now, what are the factors of 24? Well, we can have 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then we repeat ourselves. Okay, so 4 options here, and we just want to see which combination adds up to give us 11. And I can just see right away, it's going to be this one, right? 8 plus 3, that's going to give us 11. And so I'm going to then take this original expression. Let me grab another copy of this, and I'm going to split this up. So I'm still going to have a 4x squared plus something plus 6. I'm going to take this 11 and I'm going to rip it into two pieces. I'm going to rip it into a 3x plus an 8x. Okay, I get those numbers from this AC analysis that we did over there. And now because all of these terms are being added together, we know addition is associative. That means the order doesn't, the grouping doesn't matter. I can regroup the addition here, and I can put parentheses like this. Okay, now if I do that, I can now factor out a common factor from this right here. And that's going to have a common, well, the greatest common factor here is just going to be an x, right? So I can factor out an x. I'll be left with a 4x plus a 3. And then I'm going to take out a greatest common factor here. I think that's going to be a 2, right? So if I factor out a 2, I'll be left with a 4x plus a 3. And now look, I'm left with two terms, each of which has a common factor of 4x plus 3. So I can factor that out from both terms. I'll be left with an x plus 2 times a 4x plus 3. And wouldn't you look at that? That is exactly the same factorization that we got through that whole messy trial and error method. Okay, so the AC method is going to be a better way of doing this than the trial and error method with all of the many combinations. Right now I've got 8 combinations for this one. I was lucky we got it right away, but it could have been number 8, right? And the number of combinations could also be much, much larger. But the AC method is going to be a lot faster. Now there are 2 variants to the AC method. This way is sort of like factoring by grouping because we created these new groups and then we factored a number out from each of them and then we factored that common factor out again. So this was sort of like a double factoring method. Let's look at one of the variants for the next problem. For the next problem, we're going to be using the X method. This is a variant of the AC method. So what I'm going to do is I am going to create an X, and this is just a little tool to help us out. Now in this X, on the top, what I'm going to write down is A times C. In the bottom quadrant, I'll write down the value for B, and on the left and right quadrants, I will write down some number divided by A. Okay, so now in our case, what is AC? Well, AC here is going to be 6 times 12. Okay, 6 times 12, that's going to give us 72. Okay, so this is a 72 right over here. B is 17. I write that down. And then here I'm going to write sort of the a value, 6, in the denominator of a fraction. What we're looking for is what do we put in the numerator of the fraction there. Okay, now to get that, we have to do our sort of AC factorization analysis thing. Okay, so just like before, we're going to find the factors of 72 that add up to give us 17. Okay, the factors of 72 that add up to give us 17. Okay, so let's write down all of the factors of 72. Well, we have 1 times 72, right? We have 2 times, what's that going to be? 35, 36, 46, 46, 46, okay. No, 36, that is 36. And then 3, let's see, I think 3 is going to work. 3 times 24. And then 4 is also going to work. 4, we can do 4 times 23. And then 5 doesn't work. 6 works, right? 6 times 12, that's how we got this number to start with. And then 7 I don't think works, but I do believe 8 times 9 should work. And then we do 9 times 8, which is repeating. Okay, so I think this is going to be all of the factors here of 72. Let me just check. Yeah, I think that's right. Which pair of factors then is going to add up to give us 17? Well, I think it's the last one, isn't it? Right? It's going to be this last one right there. Okay, so 9 plus 8 equals 17. So what we're going to write then over here is a 9, and here, or it doesn't matter. The order doesn't matter. It could be 8, could be a 9, could be the other way. That's not going to matter. What we want to do is to now simplify these two fractions. Okay, so if we simplify these two fractions, 8 over 6 becomes 4 over 3. 9 over 6 becomes 3 over 2. Okay, so that's, I think, the way we can simplify these. Now, once they are simplified, we're going to transform these into our binomial factors. Okay. And we're going to do a kind of bottoms up transformation where the bottom number becomes the first number here, the 3x, right? This becomes a 2x, and then we're going to have a plus 4 here and a plus 3. So this should be the factorization we're looking for. Let's FOIL it out just to make sure. So first times first, that's going to give us a 6x squared. That's good. 4 times 3 is going to give us 12. Okay, so let's focus in on the middle term. That's what we have to be careful about now. That's going to be a outer times outer 9x. Inner times inner is an 8x. That gives us a 17x. So yes, that works. This is going to be the factorization. All right. So this X method is a kind of neat little tool you can use, and it's a way of sort of avoiding this double factorization that we did, right? We factored here out an X and a 2, and then the second factorization, we factored out that 4x plus 3. So instead of doing that double step factorization, that's sort of taken care of when we simplify out both of these fractions. So maybe you like that method a little bit better. Let's look at one more method that we can use. All right, so just as before, we're going to figure out what 8AC is. That's going to be 8 times 15. And 8 times 15, that's going to be the same as, well, I can think this as 4 times 2 times 15. And 2 times 15 is going to be 30. So 4 times 30 is going to be 120. Okay, so I need the factors of 120 that add up to negative 22. Okay, so we have a negative number here. And the negative number is going to be important because that's going to tell us that this is positive, right? And so this is a positive number. And so both of our factors are going to have the same sign. They're either both positive or they're both negative. But if they add up to give us a negative number, we know they're both going to be negative. Okay, so what we have to do is write down all of the negative factors of 120. Negative 1 times negative 120, right? Negative 2 times negative 60. Negative 3 times negative 40. I think negative 4 doesn't work, but we could do a 5, right? Negative 5 times, this is going to be a 24. And then 6, right? That'll work. 6 times 20. Actually, this should be negatives here. Okay. 7 I don't think is going to work, but 8 will. Okay, we can have negative 8 times negative 15. And 9 I don't think works, but 10 will work. Negative 10 times negative 12. And I don't think 11 works, and then we're right back here. So I think this is all the factors, and we have to figure out which one of these added together will give us a negative 22. And I think it is going to be this last one, right? So negative 10 and negative 12 added together will be negative 22. Okay, so what do we do with this? Well, what we're going to do is we're going to use the box method here. Okay, what's the box method? So the box method, we create this box that's going to help us factor everything out. And in this term, top quadrant, we're going to write out our 8x squared, and here we'll write our c, so the 15. And then over here, we're going to take the numbers that we just found, so a negative 10x and a negative 12x. The order doesn't matter. The next step is to take out the greatest common factor from each row and write it down over here. Okay, so what's the greatest common factor here? I think it's going to be a 2x, right? 2x is what I can take out. That'll give me a 4 and a 5, a 4x and a 5 over there. Okay, here I can factor out now I want this to be a positive number, so I'll factor out a negative 3. I think that's the greatest common factor there. Next, we look at the greatest common factor for each of these columns. And I believe here I can factor out a 4x, and here I can factor out a negative 5. Okay, so these should then be my two binomial factors, a 4x minus 5 and a 2x minus 3. And let's FOIL it out just to make sure. So 4x first times first, 4x times 2x is an 8x squared. Good. Negative 5 times negative 3 is a positive 15. Good. And then outer times outer is going to give me a negative 12x. Inner times inner is a minus 10x. That gives me a negative 22x, which is what I'm looking for. So yes, this is going to be my factorization there. And so you can sort of see we did that double factorization, the double, like factoring out the greatest common factor just by doing the columns and then the rows. So that's sort of just a different way of organizing how you do that double factoring step. All right, let's take a look at another one. Once again, we want to find a times c, right? That's going to be 10 times 14. That's 140. So we want to find the factors of 140 that add up to give us 27. That is the task that we're looking for. What are the factors of 140? Well, we have 1 in 140. I think there's going to be a lot of factors. 2 times 70. I think 3 is not going to work, but 4 might work, right? So think about it this way. If you want to make this 4, that's sort of, you have to multiply this by 2, so we have to divide this by 2 to balance it out. So what's 70 divided by 2? Well, that's going to be 35, right? 5 should work here, right? 5, I think this is going to be 5 times 28, right? So 5 times 2 is 100, 20 is 100, 5 times 8 is 40, so that's 140. 6 I don't think is going to work here because you would have to divide this then by 3, and that's not going to give us an integer. 7 I think works, right? 7 times 20, and 8 I don't think works. 9 I don't think works, but 10 works for sure. 10 times 14. 11 I don't think so, and 12 I also don't think that's going to work. So that's it, right? This should give us everything back. So let's test out the combinations here that give us 27. Well, yeah, that's pretty easy. It's going to be this one right there. Okay, so let's use the box method again. Okay, let's use the box method. So what we want is we want to write down. This is a 10x squared, and this is a 14. Over here, we're going to have. You can write this, let's do this as 7x and this as 20x. Again, the order doesn't matter. And now we want to find the greatest common factor. So here I can factor out, well, just an x really, right? I can't factor out anything else because 7 is a prime number. Here I can factor out a 2x, sorry, just a 2, so that'll give me a 10x x plus 7. Yeah, and then 7's prime, so that's it. Okay, in the column direction, I can factor out a 10x here. That's kind of nice. And here I can factor out a 7, right? So that's the greatest common factor. So what I'm saying is my factorization should be 10x plus 7 times x plus 2. And let's FOIL it out. 10x times x is 10x squared. Good. 7 times 2 is 14. Good. Now let's do the outer times outer. That'll give me a 20x. Inner times inner is a 7x. Yes, that is 27x. That's what we want. This will be the correct factorization. Okay, so it's the box method here. I think we have one more to do. So here AC will equal 12 times negative 15. 12 times negative 15 is going to give us a negative 180. So we want the factors of negative 180 that give us a negative 11, right? That's what they need to add up to. All right, I think we're going to get a lot of factors for negative 180. So here we know that since they have to add up to give us a negative number, that tells us that whenever I break this up, this is negative, one factor will be positive, one will be negative. The negative factor must be bigger, so that when I add them together, I'm going to get a negative number here. So I'm only going to consider factors where the negative number is a larger absolute value, okay? So what that means is I'm going to consider 1 and negative 180, right? 2 and negative 90. 3 and negative 60. Does 4 work here? I believe it does. I think we'll get a negative 45. 5 will also work here. We can check, but this is going to be a negative 36. Right? 6 also works. That'll be a negative 30. 7 I don't think works. And I don't think 8 works either because I have to divide this by 2. That won't work. 9 will work though, right? 9 will give us a negative 20. 10 will also work, a negative 18. 11 won't work, but 12 does. 12 will give us this negative 15. That's how we originally got that number. And I think 13 won't work in 14. So I think that's it. These are all of the possible factors. We need to identify the ones that add up to negative 11. And we can go through all of these, but I think it's going to be this one, right? 9 minus 20 equals negative 11. So let's use that. I'm going to use the original AC method, the sort of factor by grouping method. So what I'm going to do is I'm going to take a copy here, and we want to imagine this as becoming some 12x squared plus something minus 15. And what is this going to be in here? Well, it's going to be 9x minus 20x, right? So those are the numbers that we used, that we got from our AC factorization here. And then what we do is we regroup these. Okay, so let's regroup these like this. And here we have to be careful that we don't mess up these signs here. So let's just write it like this. Okay, so now we've split these into two groups. We want to factor out the common factor. Okay, so what's the common factor here? It looks like a 3x, right? So this would be a 3x times 4x plus 3. And here we can factor out a negative 5. All right, I think a negative 5. And that'll give me a 4x plus 3. And so clearly we have a common factor here. So this becomes then 3x minus 5 times 4x plus 3. And that should be it. That should be the final answer that we're getting, the factorization for our original expression here. All right, so hopefully this was a good review on how to use the AC method and all of its variants to factor out pretty much any of these quadratic expressions, as long as they can be factored. And we saw why the AC method was so much better than the trial and error method, where you had to try every combination of factors, right? Okay, so come back next time and we're going to look at some very special formulas for specific quadratic expressions that will be very easy to factor once you recognize the pattern. All right, I will see you there.